and sphere with spherical trigonometry, and then for the first term, and then the second term we get graph and separation statistic, right? And together we have some revision on trigo function. So we are going to take part second half. I think we're going getting slower than usual. Okay, we're going to take this slowly first. I think I have 2 other classes. I think they are also quite stressed also. Okay, I think for your class, week 2 we have a trigo MCQ. I think most of you finished already. Only a few of them you haven't do yet. And then for the tutorial now, okay, last week we were doing question 6 and 10. Okay, so until Thursday, okay, I think until Thursday you can submit, right? And then question 6 and 10, and I show you how to do it, how to lose 6 and 7, and then you do 8, 9, 10. Okay, for this MST, coming MST, I don't know how the format will be. Okay, most likely will cover tutorial 1 and 2, and then together with some trigo thing. Okay, most likely there's a end of term test. So I'm not sure how this work out. I need to wait for instruction. Okay, so our aim for today. Okay, I just going to up to a little bit of 1, 2, and 3. Okay, what is spherical triangle? How do you define spherical triangle, and then how to do Napier's rule to solve spherical triangle, right? I think we have a bit of time to do this, so I'm not going to rush you here. Okay, first, a bit of recap our spherical triangle. So in spherical triangle, basically they are actually form a surface of a sphere. Okay, for a surface of a sphere, and how do you call it a spherical triangle? It must come from a great circle. The great circle, which are circle pass through the center of the sphere. So what is a great circle? You can see that. Okay, any straight line. Any straight line on the sphere is actually a circle. Okay, straight line drawn on the center of the sphere to the surface is called a radius first. Okay, and then below center radius here. So otherwise, there's a diameter. A sphere is a figure that actually equal distance from the center. Okay, this is everybody knows, so I don't talk about this anymore. Okay, this is what I make sure that everybody understand. This is called great circle. Okay, what is actually a great circle here? So I have shown you example of great circle here. So let me erase this one first. Let me show you, right? So a great circle is a circle that passes through the center of the sphere. It is called a great circle. So a great circle, for example, this one is a great circle through equator, right? Equator. Looks like equator to me. Alright? And then there are small circle which doesn't pass through the center of the sphere. But there are many other great circle. So for example, you can have a great circle pass through the center of the sphere, the great circle here. Right? So great circle here. Otherwise, the rest, if the circle doesn't contain the center of a sphere, then we call it a small circle. Okay, so that is now talk about spherical triangle now. A triangle must have 3 sides. Okay, so a spherical triangle is a surface of a sphere bounded by the arc of 3 great circles. Remember, great circle must pass through the center of the sphere. So for here, this is to see an example of spherical triangle already. Three sides. Each side is an arc of a sphere. Okay, each side is a great circle. Now, for this lesson, we are going to talk about right angle spherical triangle. Okay, right angle spherical triangle. This lesson, right angle spherical triangle. Okay, this is a triangle. We have one right angle. Right angle means 90 degrees. All right, it's called right angle spherical triangle. The other triangle which doesn't have right angle maybe is called oblique spherical triangle, okay, in which doesn't have 90 degrees. All right, so they are called oblique spherical triangle. Where there's another one with quadrantal spherical triangle is one in each side is 90 degrees. Okay, later on I'll explain to you if I have time. But what you need to do is actually right angle spherical triangle and oblique spherical triangle later on. So let's look at properties of spherical triangle. This is just a quick review. Okay, if you have a plane triangle, remember, plane triangle is very special. If you draw a plane triangle, okay, let's see, in a plane, let's say a triangle ABC, straight line. Now, if for a plane triangle, angle A plus angle B plus angle C, add together is always 180 degrees. Okay, but for a spherical triangle, because a spherical triangle is formed by great circle, so you have a curve one. Let's say this is a B, C. So angle A, angle B, angle C, right? So this is angle A, angle B, angle C. Add together, always greater than 180 degrees. Okay, cannot be equal to, okay, always greater than 180 degrees, but less than 540. Okay, so for spherical triangle, the angle sum up is always greater than 180, and the less than 540. Okay, so this is the first thing. Okay, this one greater than 180 and less than 540. Okay, and then so the one on the left side is a plane triangle, which we are very used to. The other one on the right side is spherical triangle. Okay, then how about here? How do you measure the side or the length of the spherical triangle now? Okay, the other thing is this one. The side are measured in degree, minute, and second. Okay, usually when you measure the side of a triangle, usually you can, okay, this one is how many meters? So it's a 3 meter lah, nautical miles lah, for example. This is a 2 nautical mile lah, for example. This is 7, okay, 4 nautical mile, for example. So you can use nautical mile to measure the distance between A, B, and C using the, but for spherical triangle, you can use also degree. Let's say, for example, this is a 60 degree, this is 45 degree, this is 75 degree, for example. Why is it degree about? Okay, why is it like that? So I must tell you how distant I'm using measure there. Okay, so we can draw a sphere. Let's draw a sphere first. This is equator. Just give an example lah. So suppose this is the North Pole and South Pole. and then this is, let's say, 30° east. If you have a point somewhere here, there's this A, let's say this B here, simple one, because usually it's more complicated. How do you measure the distance between A, B? Usually, you can look at the distance, okay, from the equator, you find out what is this distance. Let's say this distance is 30°. This angle is 30°. Okay, this angle, let's say, is 30°. Okay, instead of using the mouse or that article mouse or meter, you're using angle now. Let's say this distance is 45°. Now from here you can find out, okay, where is the AB now? So AB in this case, based on this, you can know is 30 plus 45 equal to 75°. Okay, so instead of measure the distance using nautical mouse, meter, kilometer, you can use degree, okay, minutes, second to measure the distance between 2 points. That's why the side of the triangle can be measured in this way, right? So, okay, then what else? The sum of any two sides always greater than the third side, everyone. When you do a triangle, for example, this one, the triangle left hand side, any triangle. So for example, from left hand side, you get 3 nautical miles plus 2 nautical miles, always greater than the third side, okay, 4 nautical miles. Okay, so for example, you can third side, okay, AB 60°, BC is 45°, always greater than the third side, 75°. Okay, so this is sum of any two sides always greater than the third side. Okay, now the fourth one is an important one. The sum of three sides for spherical, right? The sum of three sides of spherical triangle always less than 360. For example, in the spherical triangle, I have the side is 60° first, plus 45° plus 75°. Okay, the three sides add together must be less than 360°. You can check that this is correct, right? So you have this 60 plus 45 plus 75, for example. Okay, 45 plus 60 plus 35. Okay, is 180. Unfortunately, always less than 13, always less than 360, right? And then equal side are equal opposite angle. So if the two sides are equal, then the angle are also equal. The last part also very typical for triangle. Okay, the bigger the angle, the longer the side. Okay, for example, from the picture of this one, okay, for example, you can find that AC is the longer side. It's greater than AB, greater than BC, right? Basically, it tells you that angle B is greater than opposite angle B is 4, right? Opposite angle AB, opposite AB is angle C, for example. Okay, and opposite BC is angle A, right? So you can do this. Same thing for a spherical triangle. The longer the side, the bigger the angle opposite the side. Okay, these are the points we note for a spherical triangle. Okay, so here we are going to apply to right angle triangle first. Let me see who is not here yet. So I want to make sure everybody is here first. So now we're 16, I think I have Still two people, there. Not missing here. Okay, 3 people haven't responded yet. Oh, this is important. If you don't respond, I don't know what happened. Okay, so let's record this session first. Oh, somebody recording it now. Okay, so fine. Okay, good. So this one is about right angle triangle. I mean, one of the angle is 90 degree. Right angle. So one angle is 90 degree now. So let's see how to do this triangle here. I have a triangle. Let's see a ABC where C is a right angle now. Okay, so you can see that C is right angle now. So you label the triangle where C is right angle. Okay, ABC. So the side opposite angle A is small letter A. The side opposite angle B is small letter B. The side opposite angle C is small letter C. Right? This is how you label the triangle. Okay. So what we're going to do is do something called the Napier's view. Okay, Napier's view. Okay, let me highlight here. Napier's view is actually this one. Napier's view. Okay, what is actually Napier's view? Okay, it's a view. I think you might probably have seen before. So this is view here, where you have on top there are 2 parts. Then divide the part, and bottom you divide the 3 parts with a complement inside there. Okay, so you guys can imagine that this is, I'm not sure what you can have anything can associate with this as funny shape there. Okay, this, okay, what you do is at the center you place the angle which is 90 degrees. So this is 90 degree here. So center you place a 90 degree here. Okay, C. Okay, C is a 90 degree. Okay, 90 degree. Now you're going to trace the triangle clockwise. Okay, because convention is trace the triangle clockwise. So you go clockwise. This is how you clockwise here. Go clockwise here. So you trace the triangle clockwise. So from the part, let's say, before you enter C here, you have the side A. So this is first, let me see here. So the first thing you go into the triangle is this is 1. A. Okay, A. Okay. So C, you already right in the middle away, don't write now. So the next thing is continue to trace. Okay, continue to trace the triangle here. The next thing you get is B. Okay, so this is B now, side B. Okay, then after you trace B already, the next thing you encounter angle now. This angle is 3. Okay, angle is 3 now. Let's say, let me erase this one now. This angle is 3. So this angle A now. So you can put A, angle A. Okay, then if you continue to trace, you go there, side C, right? So side C. Okay, so you can put a C now. Then after C, you can encounter another angle. So this angle is actually this 4 now. Okay, this 4. Finally, 5, angle B. Okay, angle B will be this one. Okay, so this view is called the Napier's view. Let's look at how I trace the diagram. 1, 2, 3, 4, 5. Okay, then let's look at how we apply the Napier's view. The rule is here in the upper part. Okay, the rule is in the upper part here. So this is the rule here. How do you use the Napier's view? Okay, before I use the Napier's view, I must tell you how do you actually use it. The rules is very simple. 2 rules only. Sine of the middle part is product of cosine of the opposite. Sine of the middle part is a product of the tangent or adjacent. So actually you can product of opposite, product of cosine or opposite, or product of tangent or adjacent. Okay, or under sine of middle part. So let's see any example here. Okay, so let's say I want to use this to get started. Okay, so first of all, let me highlight something, then you can see the better here. So let's say this is the middle part. Okay, I use yellow for middle part here. So okay, middle, yellow part. Okay, yellow is the middle part here. And then there are 2 next to it. It's called adjacent. Okay, so next to it is called adjacent. So yellow, green one is called adjacent. Adjacent and middle part. So this is called adjacent. And then the one opposite the adjacent, we'll use color here. So these are called opposite. Okay, so opposite, okay, is a opposite yellow part. So I use this as an example to tell you how to apply this rule. For example, if I want to find sine of middle part, so sine A, okay, sine A. Okay, so I want to put some more here because A has a complement there. So basically, the complement sign here, that means that this is actually complement of A. Okay, because of complement at the lower end. So sine of complement of A, okay, complement of A is actually yellow one, okay, is equal to product of depend on what you choose. If you want to choose adjacent, you must product of tangent. So product of tangent is adjacent here. So this is product of tangent here. Tangent. Okay, one of them is B. The other one is tangent. Complement of C. Okay, so I use adjacent, green color. Okay, product of tangent, so sine of complement of A, where because of complement sign, so the complement applied to a lower values. So tangent B have no complement, but C has complement, right? So complement of C. So next I want talk about what is complement later on. So then, if I want to continue, let's see this one now. Okay, I can also sine of complement of A, where A is the middle part, because I use yellow here, become the product of cosine now. Okay, product of cosine. Cosine of what? Opposite. One of them is cosine of A. The other one is cosine of complement of B, opposite. Right? Okay, so complement of opposite of B of A is complement now. So this one is actually the blue one, opposite. Okay, so in this case, what is complement of A means? Okay, so complement of A, as I explained to you, complement of A basically means 90 minus A. Okay, complement of B means 90 minus B. Whatever it is, just 90, you take away this. So this will tell you how to apply the Napier's rule for a right angle triangle. So you put a right angle triangle where C is at the center, okay, the top of the view, divide the top into two parts. Okay, then you must trace the clockwise, alright? So trace the clockwise, you get all these things. Okay, then yeah, 5 parts there. So they are side adjacent to the middle part and 2 sides opposite the middle part. Okay, this is what apply here. So we are going to give you, okay, then let's do the summary. Okay, the step of solving the right angle triangle. Okay, so you must have right angle triangle first. So if you do a right angle triangle, then it's a hard one. So for a right angle triangle, you trace the circle. Okay, write down the given part, and then you can draw a Napier's view. From the Napier views, you see what formula you need to use for the unknown part. Okay, so usually you have usually you have 3 remaining part. Okay, usually you have 3 remaining part. Okay, so before you check here, so we are going to do example 1. Okay, do this example slowly, right? To actually see how you apply the Napier's rule. So first of all, notice that this is only for right angle triangle. Right angle spherical triangle, right? If a spherical triangle is not right angle, you have to do a lot of work here. So in a triangle PQR, Q is 90 degrees. Where is 90 degrees? So you can draw a triangle there. So let's draw a triangle. So I'm going to say P, Q, and then R. Okay, each side is a great circle, part of R great circle. Okay, so Q is 90 degrees. Angle P is 45 degrees, so this is angle P now, 45 degrees. And side R, where is R here? R is actually the side opposite angle R, so this one is actually 60 degrees. Okay, remember, the side now can be measured in degree, right? Now, okay, instead of measured in nautical mile, kilometer, now it's measured in degree now. Okay, so using degree measure to tell you how long is the side here. So Now you're going to apply the Napier's view to solve this triangle. Okay, there's three things you don't know. Okay, let's see what are the three things you don't know. Okay, you give you enough information or not. Okay, so you draw a Napier view. It's actually like this. Okay, top divided into 2 halves, bottom divided 3 halves. Okay, I have this one, not so good. 3 halves, right? So again, for this bigger space. So this is a column here. Okay, then you trace a triangle. Okay, trace a triangle clockwise. So you put 90 degree at the top there. This 90 degrees happen to be Q here. So you put a Q here. The angle Q. So where does it go to angle Q? So first of all, you can, okay, let's see, okay, so they go into Q, the side is a QR first, RQ, right? So RQ, what is it? RQ in this way is called P, right? Small p. Okay, small p, RQ here. Okay, small p, RQ. Then go into Q first, then PQ. PQ is this is the P here. PQ is R, which is 60 degree. Okay, from P to R. So actually I have moved from here. So you can look carefully. P to R first. So I move from P. Okay, then the Q angle Q, then Q to R. Then I encounter the angle P, right? So this is the first encounter, this second encounter, the third encounter is angle P now. So this P is angle 45. So this big angle P here. Okay, then the fourth encounter is here now, is PR. So PR is actually the side Q. Opposite the angle Q is side Q here. So this PR is Q here. So this is Q here. Then meet the angle phi R. So this is angle phi here, angle R now. Okay, so this is a typical view, right? So depending on how you trace it, so I draw the RPQ in this way. Okay, so first you construct a Napier's view first. Okay, now I'm going to find out what do I know now. So I have which are the things you don't know. Okay, so the things you don't know, you have to figure out how to find them. So let's see, things you don't know. Okay, let me use a color I not used before. Okay, the things you don't know is actually this one you don't know. Okay, this one you don't know. This one you don't know. Right, these are 15 you don't know, right? So let's see what you can find is based on what now, okay? So many ways you can find it. I'll try to make it simpler here, okay? Try to make the simple one. So I want to find the angle R. Can I do that? I try to get the simple version, angle R first. Okay, angle R. Okay, let's try. I just pull it to next one. Edit, selection tool. Okay, let me see. Okay, edit, selection tool. I want to get an angle R now. Okay, sorry. Okay, let me say copy the page, select page, edit, copy, page, right? Then I'm going to put it here. So let's try. I want to find R first because R, I think, is one of the easier part, right? Find R first. Find angle R. Okay. Because why? R is the easiest one because from here, I just try to make things as easy as possible. So this is the one I want to find. Okay. Okay, how to find angle R? And I'm not necessary to go through the step. Okay, just because you can find P first and pi R, but I think easier one is pi R first. Why R is easier here? Because sine of angle R, sine of R here, okay, sine of complement of R, okay. R has complement because R is actually below the view, okay. Sine of complement of R here, it's below the view now, is equal to, there are two things opposite R, which I have here. Opposite R, so you use it's a cosine, right? So this is equal to cosine of, okay, I want to erase this triangle now. Okay, erase this triangle, no space already. So let me erase this triangle here. So this is equal to cosine, okay, opposite. You have cosine, product cosine now. Cosine of R and cosine of complement of P. So this is the cosine R, cosine P, product cosine, right? So I need to tell you a few transformation. So what does the complement of R means? Okay, I can draw a simple triangle to tell you. Okay, complement of R, let's say angle here. Let's say this is R here, 90 degree. This is 90 minus R, complement of R. Okay, let me draw a bigger triangle. And why complement of R first? Maybe I insert another page to tell you. Okay, big triangle. So let's say this angle triangle. This is R here. This is complement of R. So what is sine of complement of R? Okay, for a right angle triangle, let's say this is Y here, this is X here, this is hypotenuse here, HY, right? Okay, hyper. Okay, hyper here. So sine of 90 minus R, we know is actually opposite over hypotenuse. So it's X over R. Okay, X over hypotenuse. Okay. But X over hypotenuse is actually the same as cosine R. So generally, sine of 90 minus R is actually the same as cosine R. So you can see that, all right, next time I see sine of 90 minus R, this is actually same as cosine R. Okay, how about the other one? Let's say I want to know what is cosine of 90 minus R. Okay, cosine of 90 minus R is adjacent, which is y, over hypotenuse. Then this actually sine of R also. Sine of y is actually y over hypotenuse, right? So you can actually make use of that. Cosine of this is sine of R. So from here on, I got to simplify my equation. Okay, whenever I complement of an angle, take sine, I get cosine R. Okay, cosine of complement, it becomes sine R. So from here, you can simplify this now. Okay, so this is actually sine complement R is actually the same as cosine of R. Okay, so this is cosine of small r here. Cosine complement of A, you know, is sine. Now, okay, so this is, find out, this is cosine of 60, sine of 45 degrees. So you can check what is this thing now. So cosine of 60 times sine of 45. Okay, so this is equal to 0.3535. So R is equal to inverse cosine 0.3535. Okay, this will give you, okay, shift cosine inverse. The answer 69.29, which is convert to degree and minutes, which is 69 degree and 18 minutes. Okay, this is how you find R first. So I find out the R is actually 69 degree, 18 minutes. All right, so this is how I find R here. Okay, so if I find R already, now let's say how to find, let's say next one, easy one. Okay, so R finished already. I need to find P. How do you find P here? Let's see, this time I want to use R as a middle now, okay? Then I put an adjacent. So I use tangent now, okay? Or you can find the Q also, but Q didn't want. So let's find the P now, okay? So I want to insert in the page here. So copy the page first. So insert next page to find P. So R I finished already, which I write down is 69 degree 18 minutes here. Okay, now I want to find P. The side P, right? The side P, small p, which is a R cube. So let's try this now. I'm going to use this time I'm going to use the adjacent now. Okay. Okay, so I'm going to use the adjacent of P, right? P is okay, so no good, no good. Okay, let me, okay, anyway, so I'm going to use this. I'm also, okay, so I use the change color now. So I'm going to change the yellow one. Okay, color one. So this one, I want to use the green color. Okay, so let's recolor it so that it's color here. So I want to make the middle one the yellow. So okay, middle one yellow. Okay, and then the next adjacent one I want to use green now. So the formula is for adjacent. You know the sign of the middle one, sign of P now, sign P. Okay, sign of P1 is equal to tangent of adjacent. So one of them is R, comma R. The other one is product of small r. Okay, so whenever you do adjacent, you do product or tangent. So product or tangent. Okay, and then this middle part we want to find. Okay, that part is product or tangent. Okay, so what is com tangent of com r? Which you know r already, so actually it's not too difficult. Okay, tangent of com r. But anyway, you can find out what is this thing. Okay, let tangent of com r is actually tangent of 90 minus 69 degree 80 minutes. Okay, times tangent of, okay, comma means 90 minus r. R is 69 degree 80 minutes here. Tangent of 60 degree. So you can press the calculator to find out what is sine P, right? So P is equal to, so we get tangent 90 degree minus 69 degree 18 minutes. Press the calculator times tangent of 60 degree, tangent of 60 degree. All right, so let's see what you get now. This is actually 0.6544. Okay, 0.654487 and so, right? So P is equal to sine inverse of 0.654487. So sine inverse now, shift sine inverse of answer, you get 40.88 degree. Which is around, convert to degree a minute, which is actually 40 degree 53 minutes. So the length of R cube. This one is 40 degree, 53 minutes. Right? So this is the side P. Okay, so basically I answer the question already. Okay, basically I answer the question already. How about now? Then the find Q, right? So let me go back the last few things and WhatsApp to you the page first, right? Okay, let me go back to WhatsApp the page to you. So this is find R first. Okay, first a few things. So this is how the page look like. So you start with join triangle first. Okay, join triangle first. Then this one is not really here. This will tell you, explain to you how to comp. So then you look at how to convert the comp. So this is find R here. Okay, and go back. This is how I convert the comp for triangle. And then this is how the P. So that means that I finished the question early, except that I did not find R, right? How do you find except Q, right? I can continue to find Q. Let's see how I find Q, right? So page page first, select page first, then edit, copy page there. So I want to move on to another one. I want to show how to find Q, right? Almost done. And one more time to find Q now. So let me erase all these things now. Okay, other question they ask of Q, so I want to find Q. Okay, so I usually like to use cosine. So let's try. So I want to use cosine now. So I want to make this the middle one, the yellow one. Okay, so I want to make this cosine here. Okay, so cosine now. I want to change it to blue now. So cosine, right? So let's try. Say I want to use cosine. Use the blue color for cosine one. Okay, so find Q here. You can actually sine of Q here. Sine of Q. Sine of Q. Now Q is in the lower part, so it's comp Q. Okay, sine of Q, comp Q here. Okay, then product of cosine now, because opposite is product of cosine, so it's cosine of P. Cosine of R. Okay, then we know that sine of comp Q is same as cosine of Q. Okay, sine of comp Q is same as cosine of Q, and this is cosine P. Cosine of P is 40 degree, 53 minutes. Cosine of R is 60 degree. So now multiply them together. Cosine of 40 degree, 53 minutes, times cosine 60, (0.3780). So Q equal to cosine inverse 0.3780. Press calculator. Okay, inverse cosine, answer 67.67, 789, 79, right? So this is actually convert to degree a minute, it's 67 degree 47 minutes. And so this is Q. Okay, this tell you that how do you apply the Napier's rule to solve the right angle spherical triangle. Okay, so this is actually a quick revision of Napier's rule. Okay, this is example 1. And next, I don't want to continue because I think it's too much already for this example. Example 2, just earlier, I have a class in O1 or 2, then overshoot time, okay? So cannot do this over one lesson. So next lesson, I will try to do this with you. So example 2, if you know how to do this, right? Example 1. Okay. Example 2 is an oblique spherical triangle. Okay. Napier's rule, if you have an oblique spherical triangle, means the angle is not 90 degrees now. Okay. Then you must split the angle. Okay. You must split the triangle so that you get two right angle triangle. Okay. Split the triangle. It's necessary to divide the triangle into right angle triangle. Okay. Two right angle spherical triangle. Then you must drop the perpendicular in such a way that the two of the null part are in one of the right angle triangle. The null part must be in one of the right angle triangle. Okay. Null part must be in one of the right angle triangle. This is the hint. How do you drop the vertical? How to actually drop the vertical line? Okay, to make a 90 degree. Okay, but I'm not going to go through this because that will be not enough time. So let's see mark attendance first, right? Because there's not enough time to go through the next one. Because they'll be very rushed. So I will not go through that, just mark attendance first. Okay, somebody is absent today, or so many. Okay, so I can stop right now.